So in first BSc Mathematics, we'll be having a paper integral calculus. So in that paper, we are having a separate unit called beta and gamma function. So today let's study about beta and gamma function. So without getting into the topic in detail, let us start with a simple question. So we all know the concept of factorial, right? What is a factorial? For any positive integer, for any positive integer, the factorial, for any positive integer, the factorial is defined by n factorial, right? So what is n factorial? N factorial is n into n minus 1 into so on into 1. So this is n factorial. For example, if you are having 3 factorial, then we will be having 3 into 2 into 1, which is equal to 6. Okay, and for 4 factorial it would be 24. So these formulas we will be knowing. Okay, so a natural question arises, right? So can we define a factorial? This is for integer. For a positive integer, we can have the factorial of any positive integer. So what would be the factorial of non integer value, right? So we are having a question. What would be the we can find the factorial for any positive integer, but what would be the factorial of a non-integer value? Like example, what would be 1 by 2 factorial or 2.5 factorial, like that, right? So for the finding the factorial of non-integer value, so this leads to the definition of gamma function. So this leads to the definition of gamma function. So one of the most important two functions that we will be studying in mathematics is beta and gamma function. So we can say, in other terms, we can say the gamma function is an extension of the factorial function to real and complex numbers. Okay, we can say like that. And this gamma function and beta functions, both the functions are indefinite, that means improper integrals. Okay, so now without getting delay with this introduction, let's get into the definition of gamma function. So gamma function, it is defined by the improper integral. So we all know what is an improper integral. Okay, so the notation gamma function is denoted by gamma of n. Okay, and is defined by integral over 0 to infinity e power minus x x power n minus 1 into dx where n greater than 0. Okay, so this is the definition of gamma function. So gamma of n is equal to, so we have told no, it's an improper integral, so the integration is from 0 to infinity e power minus x power n minus 1 into dx where your n is greater than 0. So this is the definition of gamma function. So under this we'll be having few properties. So we'll see in detail about those properties one by one. Okay. Okay, so gamma of n plus 1 is equal to integral over 0 to infinity e power minus x power n plus 1 minus 1 into dx, and here plus 1 and minus 1 will get cancelled, so we'll be having gamma of n plus 1 is equal to integral over 0 to infinity e power minus x power n into dx. So now let's make use of the formula integral over u dv. So consider let u to be x power n and dv is equal to e power minus x. So what is du? Du is equal to n x power n minus 1 into gx, and v is equal to, we'll be having minus e power minus x. So when we are going to check for the limit values, when x is equal to 0, u is also 0. When x is equal to infinity, u is also infinity. So there is no change in limit values. So now we can directly use the formula. So therefore what we'll be having, which is equal to uv minus integral over v du, right? So u and your v is minus e power minus x, uv minus integral over v du. So minus into minus will become plus e power minus x v into du. So n is a constant term, so you take it outside. So inside you will be having x power n minus 1 into dx. So when you are substituting the limit values here, the first term will become 0 because it's a multiple of x. So when you are having the lower limit, it would be 0, and e power minus infinity also it would become 0. So the first term will become 0, plus we'll be having n into integral over 0 to infinity e power integral over 0 to infinity e power minus x power n minus 1 into dx. Now what is the definition of gamma of n? Integral over 0 to infinity e power minus x power n minus 1 into dx, right? So this is nothing but n into gamma of n. So the first property we have proved is gamma of n plus 1 is equal to n into gamma of n. Okay.